So our butane will have 4 carbons. So then I use my HCnH2n plus 2, so it should be H8 plus 2, which gives me H10. So if you move carbon, or a CH3, because that is technically what is called a branch, you need to draw a structure that is, but you can't have 4 carbons in a row. So this now is going to be a little bit difficult, because technically if I could see your books, it's an easier thing for me to see than it is here. But anyone know where I'd stick my carbon? So I'm going to number my carbons here, and we'll talk about numbering to do with naming. Doesn't matter if you number them right to left or left to right, as long as you know you'll know where carbon 1 is. So of those 4 carbons, if I was to remove this,
would you put a carbon on the far side of the H?
so it's this carbon I'm moving, because with the compound when I'm done, I'm going to have CH3 is the formula still going to be C4H10. So where could I put that carbon so it's not in a straight line? Okay, so tell me what you think. So this is my butane. Where could I put onto what carbon number for the 4 that's listed there? Where would I put 1 so that it's now not 4 carbons in a straight line anymore?
I got the second one.
Okay, so I'm going to take this one off at the end. We're going to go off the second one, like so. Okay, so straight away you can see here, I have my hands on what is carbon number 2 in my diagram. Whatever way I put my fingers, 1, 2, 3, that is 3 carbons in a row, and this direction it's 1, 2, 3. That is an isomer of butane. If I had decided that I'm just going to move it and put it on to a different carbon, or it's always going to, you have to see, can you see it in a straight line? So you're always looking for a straight line in some ways. So if I was then making my different version of butane, I would put a carbon here, and I put this carbon into the middle, and then I fill everything else with hydrogen. Okay. Oop, fill everything else with hydrogen. There's a glare in here. And we'll talk about naming this in a minute, but no matter where I put this, this is 1 carbon in a straight line, this is 3 carbons in a straight line, going back this direction is 3 carbons in a straight line. So that is different, a different structure. These are 2 different structures up here. Okay, are we as happy as we can be with that?
You don't write an extra pair of H's, do you?
No, so if you count the formulas that are there, the formula for this thing down here is still C4H10. That doesn't change. What changes is the structural arrangement. So the molecular formula stays the same, C4H10. It's just how they're organized is different. And I will keep saying it, you look for your carbons in a straight line, no matter what. So the formula will stay the same, it's just the arrangement is now going to be different. Now you should have a gap on page 164. I'm going to see, will it let me erase it? Will. So I'm just going to get rid of these. No, won't let me erase. Yes, it will let me erase. Okay, so this is the posh diagrams. No. Why are you now not letting me do? Okay, so you probably have not heard, but there's a group, they're called IUPAC, so International Union of Pure and Applied Chemists, and what they do, or what they did, is they got together and they decided the rules for naming compounds and isomers and all different weird and wonderful, and that's where the meth, eth, and prop comes from. So you now know, while you don't know what the structure is, you know for ethane, ethane, ethyne, you'll know how many carbons are in there, and the rest of it will come. But these guys decided what it is. So we have this definition of structural isomers. So I think that is going for you on the top of page 165. So structural isomers are compounds that have the same molecular formula but different structural formulas. And the structural formulas are what we draw with the elements, symbols, and the lines. So it's not any type of bubble or circle. It is elements, symbols, and the lines. And we would be sticking what are called side groups on to them. So these are our two things. So our butane, and the name for this particular compound down here, and we'll explain how we get to the name in a second, is called 2-methyl propane. So prop comes from how many carbons in the main chain? And this is telling me where and what my side group is. Where and what, and it actually tells me how many carbons are in my branch or in my side chain. Okay, so this is kind of like an address of where I put the side groups. Now, if you want to, next to where we have the 2-methyl propane, just make a note for yourself. Alkanes, if we make isomers of alkanes, we do it by making a branch. That's the only thing we can do with alkanes. When we do alkenes, you'll find out we can do more things. So we make a branch. That's what's going to make our isomers of alkanes. Whereas when we do alkenes, we can make branches, we can move double bonds, we can turn things into rings. But for now, alkanes only make branches.
Oh, Miss, what you put up the top there? The chains are generally called, main chains are generally called.
No, so this down here, is this part you're talking about?
The side up top, but under the definition, the side groups of main chains are generally called.
Am I looking at a different screen?
In our
It's
book.
in the book.
In the book.
We haven't gotten to that yet. Okay, so ours, we as comfortable as this as we can to begin with. So we have molecular formula stays the same, structural arrangement is going to be different. For alkanes, we make isomers by moving a branch or by making a branch. And in terms of our naming, the propane part is going to tell us how many carbons in our main chain, and then we have a number and a side group, and it tells us where it is, what it is, and how many carbons are in that particular branch. Okay, so on to the next part.
Why is it 2-methyl propane?
Because it doesn't matter which way you go from left or right for propane, because carbon 2 is always in the middle, but this is why it's number 2, because it's at position 2. So it's telling you at position 2 you have a methyl group. This is a methyl group. And this is your main chain of 3 carbons, and that's what makes it your propane. Okay? So the side groups are called alkyl groups in just a general term. So if one carbon is methyl or methyl, what do you think I'm going to call 2 carbons from your naming?
F.
Yeah, ethyl or ethyl. So an ethyl group is going to be C2H5. If you had to bet my lovely mother-in-law 3 carbons. So you got to think monkeys eat purple. What's the 3?
Propane.
Propyl. So if you had a 3 carbon side group, it would be propyl, and it will be 1, 2, 3, and you fill everything else. And so this is where it's attached to your main chain, and then this is where it comes underneath. So their alkyl group is just the general overall name, but you will be adding a methyl or an ethyl or a propyl if you do so. The reality is, for us, it's usually methyl groups at Leaving Cert that we add on. Okay, so we're going to give a compound, we're going to do the rules for naming. Okay, are you happy? For the heads I can see. All right, so you have this compound. So can you see that this could be the main chain, this could be the main chain, this could be the main chain. There's 3 versions in there of what could be the main chain. Can you figure out for me where is how many carbons is in the longest chain? So whichever way you look at it, how many carbons do I have?
6.
Have 6. So what's the ending of the name going to be? 6 carbons makes it what? Makes it hexane. Now, you can decide, there's a ruling for where you number your carbons, and you usually number them from where your branching starts. So this is going to be carbon 1, 2, 3, I'm going to go name it this way, 5 and 6. Okay, so you find the longest chain, and as we've said, it mightn't be in a straight line. So 6 carbons, its ending of this particular compound is going to be hexane. Okay, so now, what carbon numbers do I have my groups on? Okay, so what carbon numbers have my groups?
2 and 3.
2 and 3. What is the side group on carbon 2? So what is this side group called?
What's the question?
So we, either Jill or Sarah, I apologize for not knowing which one because I wasn't looking at the screen, is 2 and 3. What is this side group on carbon 2?
Is it methyl?
It is a methyl, because it's not methane, because methane is CH4, but it's derived from methane, so it's CH3 is methyl. And what's this one on 4?
Methyl.
Or on 3 is ethyl. So I now have 2 side groups, 2 methyl and 3 ethyl. There's a rule once you get side groups with different numbers, and the rule is they go alphabetically. So in terms of putting pits on the name, it will be 3 ethyl and 2 methyl. So it goes on the initial rather than the number of the group. Okay, so this particular compound down at the very end, its full name is now 3-ethyl 2-methyl, which is spelled they're both spelled incorrectly, are they? No, they're not. Yes, they are. No, they're not. Yes, they are. And the last rule that we have to apply, and when we do fuels, there are 2 hydrocarbons you have to know because they use it to rate fuel or rate petrol. If you have 2 of the same group, you have to use the number twice, and you have to put how many of those things are there. So 2,2-dimethyl, if this was a 2,2-dimethyl, you'd have a C here and a C up here, because there are 2 of them. Now when you're drawing, it doesn't matter if you put your methyl group above the carbon chain or below it. It doesn't care, as long as there's only 1 of them. That will make it a 2-methyl group. Okay, so this last rule doesn't actually come into effect for this particular compound, but it's something you need to be aware of. So you may have to use the number twice and use a prefix to distinguish, to tell somebody what to draw from a name. Okay. So over the page, on top of page 166 for me, it's asking you to draw some structural isomers of C5H12. I'm going to flick. So what I will tell you is if they answer the question this way, you can give them 3 different isomers. If they specifically say structural isomers and they use the name, you can't give pentane as an isomer. So here you can give pentane as an isomer because they've only given you a formula. But if they give you the name, you can't give them 5 carbons in a row. So do you think you might like to see, can you draw 2 isomers of it? Ask questions and then we'll check through. So you can use your little mollymods and your marshmallows.
Isomers meaning like not in a straight line.
Not in a straight line. Isomers meaning. So if Mikey, they give it to you as C5H12, one of the isomers is the thing in the straight line. But if they give you the name pentane, one of the isomers is not one of the ones in a straight line. So just be aware how they're asking you the question, because you'll be able to draw the isomers. So you can use your little homemade mollymods. I'm gonna go start breaking things up. Okay, and just be aware of where you're putting your branch so that it's not at the end. And see, can you name it while you're doing it?
Can you do one above and below?
Absolutely. So, and you just always have to remember that you have to have 5 in total. So make sure that when you're doing your one above and one below, that you're still left with 5 carbons at the end.
Miss, what does it mean by finding position of alkyl groups?
So the branch that you've put on, so what carbon number is that branch on? And remember, we number from the lowest number possible. So if you had like an 8 carbon something, you'd never say 7 methyl, it would be 2 methyl. So you're telling what carbon number that side group you've drawn is at, and then what number that carbon is. Start as and making it as low as you can. So for the way this question is asked, one of the structural isomers I can draw is actually pentane, because it's just given me a formula, so I can draw whatever I want. So that to me is a logical thing to do. Okay, so this is pentane. So what would be the next isomer I could make? Or the first isomer? How many?
3 in a line, and then the middle one above, one below.
Okay, you've gone to DEFCON 1 already, Mikey. I like it. Okay, so yeah, 3 in a line. You can put 1 above. Now, can you name that? Good times. What is the name? Ooh.
Okay,
So, how many carbons in your main chain?
3.
3.
Oh.
So 3 makes the ending what?
Propane.
So my ending is going to be propane. So the next thing are my groups. So what position are my groups, and do I need a prefix, and what are my groups? Anyone can feel free. Yeah, go Mikey.
They're second, so
Yeah.
both second.
So I have to go
They're
2,
both
2.
2.
Yeah.
And then so it's gonna be di.
Good man. So what is the group?
Methyl.
Methyl. Okay, so it is dimethyl. So this is called 2,2-dimethyl propane. And that's really good because you need this part and you need this. So what you're trying to remember if you have to name something from a formula is you look at the formula and say, if I was to draw that, does that actually represent this? So the most common mistake is people might say 2-dimethyl, but actually you have this bottom one is at carbon 2, this top one is at carbon 2, so you're putting in the 2,2. There's one other version between pentane and 2,2-dimethyl propane. What's that one? So this is your 2,2-dimethyl propane, 3 carbons in a row, no matter what way I orientate it. And off my carbon 2, I have a branch and a branch. Okay, next one. What's the one in the middle of it?
I just put it over the 3.
Yeah, but so you now need to make me a third one, Mikey, to get your mark, the last bit of marks.
So like 4 C's in a row.
4 C's in a row. Okay, 4 C's in a row. Where am I putting my side group?
Above the third one.
So in this one, again, we've said you can either put it off this one or this one, because and either way you put it, that will be carbon 2, no matter where you put it from, just because you have 4 carbons in a row. So I'm going to put it off this one. So what's the name of this thing now?
So it's butane.
It is a butane.
And it'll be 2 methane.
So it's not methyl, yeah, it's methyl or methyl, whatever pronounce you want to do it. Okay, good job. So all have a formula of C5H12, they just have different structural arrangements. So either of these carbons down here that I put the kind of funky asterisks, either of those carbons could be carbon 2, because you always name a number from the lowest carbon. So this is carbon 2 going from the left, this one over here is carbon 2 going from the right, doesn't matter. So the last bit I think that we're going to do today is the bottom of page 166. Could you draw the structural formula for that name? So you work from the end of the name, you draw your main chain, number your carbons, shove your side groups on. So you start from the end of the name, draw your main chain, shove your side groups on.
It always says die.
Yep. So what
Does
does
that mean there's like?
go,
Does that
Mikey?
mean there's one above and below on the same line?
So no. So you have numbers. So there are 2 ethyl groups along the main chain, and the numbers tell you where they are. Does that make sense? So there are 2 ethyl groups along attached to that hexane, and the numbers tell you where they go.
Okay.
So naming from the end, hexane is 6 carbons. I can number from left to right or right to left. So for this excitement, I'm going to go from right to left. Doesn't matter as long as it's going to match your name. So I know at position 2, I have it's 2,4-diethyl. So I go
Okay.
up. Yeah,
My screen is frozen.
thank you. So I have ethyl at 2, and it doesn't matter if I put it above or below. And I have an ethyl at 4. Ethyl. And I make sure I filled it all with hydrogen. And I also have here a 4-methyl group. So at position 4, I add on that branch. And then I make sure every other single bond is filled with hydrogen. Because sometimes people, down here, here. Okay.
Please, if it says like 2 and 4, why are you starting the chains from the third one and the
No,
fifth one?
okay, I'm gonna see can this let me change my pen color. So this is carbon 2. On carbon 2 and 4 I have no, it's not what I wanted. On carbon 2 and 4 I have an ethyl group, so this one is on carbon 2. Don't like that color. That one. And at carbon 4, this is the other ethyl group. So that's the 2,4-diethyl. Okay, so carbon 3 just has hydrogens on it.
You'd go for over C5, but would there be another H then?
There should be,
Is that
thank
that
you,
chemical?
Mikey. Yeah, that is absolutely correct. So this sometimes is the problem when you start drawing isomers, because you think you filled in all your lines and you haven't, so you really have to check. So good spot, Mikey. And then this is my 4-ethyl at carbon 4, or sorry, 4-methyl at carbon 4. Is that okay, Miles? Okay, if you're content, the last thing I just want to show you is at the bottom of page 166. You don't need to see these, blah, blah, blah. Nope, excuse me now for 1 second. Okay, we go out. Okay, so the last thing that I just want to show you is you can, if they ask you to give a kind of a drawing or a formula, they will accept sometimes what's written at the bottom of page 166. I don't know why this won't now go black for me. Excuse me, thank you for your patience. So the formula that they have given you is CH3CH CH3CH3. So anything that's in brackets, this is going to be a branch. Anything that's outside of the brackets is showing you the main chain. So in this particular compound, there are 3 carbons in the main chain, and off this particular carbon here, you have a CH3. You have a CH3 and you have a H, and then these are the CH3s that are at the other end. Okay, so anything in brackets is a branch, and you then fill. So this CH is this CH. This we've said is the branch, this is the branch, and these are my terminal carbons here and here. So what is the name of that? What's the longest carbon chain? What's the side group? Any takers?
2-methylpropane.
Boom. Okay, so it's 3 carbons in your main chain, no matter what way you look at it. 3 carbons here, 3 carbons going up here, 3 carbons going down there. So that makes it a propane, and then on carbon 2 I have a methyl group. Okay, so usually from the diagrams they gave you, you'll be able to name, and you'll get it right. As we say, the issue comes with something that you've drawn and not recognizing how many carbons are in a main chain. Okay, so there are some, I think it's book questions and a couple of structures for you to try and draw. The only thing I'm going to say is you have to draw a cyclo compound. So cyclohexane, I think, is what it is. So if the word cyclo is in a name, you have to turn that into a ring. So this will be a 6 carbon ring. It's not a benzene ring because it's not an aromatic. But if you see the word cyclo in front of something, it's a ring is what you have to draw. Okay, so give those a go for homework, and we see each other, I think, on Friday. Friday. So if you're happy, I'm happy. Alrighty.
Thanks, guys.
Bye.
Okay.